So, you've always wanted to get into electronics, but maybe you didn't know where to start. Well, you've come to exactly the right place. Think of this as your orientation, your very first step into this incredible world of circuits, components, and creating cool stuff. Let's jump right in.
Look, forget about all the complex math and heavy theory for a minute. The journey into electronics really begins with discovery. It all starts with something you can actually feel. You know that little zap you get when you touch a 9-volt battery to your tongue? That's it. That's your first real connection to the flow of electricity. And honestly, that's where we begin.
So, where does all this electricity even come from? And here's the amazing part. You can make it yourself with stuff you've probably got just lying around the house. It's not actually magic, but I gotta say, it sure feels like it at first.
Yeah, I'm talking about the classic lemon battery. If you just stick a copper penny and a zinc-plated nail into a lemon, you create a tiny chemical reaction that generates a real measurable voltage. It's the perfect example of how the fundamental ideas of electricity are literally all around us, just waiting for us to play with them. And the best part about learning this way, by just doing it, is that you don't need to know anything beforehand. You can just start building and experimenting right now. This entire series is designed to get you hands-on from the very start.
Okay, so to really get a grip on circuits, we need to learn to speak their language. And believe it or not, that language was basically written for us by a handful of incredible scientific pioneers.
We're talking about absolute giants here. Guys like Volta, who figured out how to make electricity from chemicals, Ohm, who defined the concept of resistance, and Faraday, whose work gave us electric motors. Their names aren't just in dusty old textbooks. They are the actual units we use to measure electricity today. We'll get to know all of them in way more detail in future explainers, but for now, let's start with the man who invented the battery. So let's start with this guy, Alessandro Volta. His big breakthrough, discovering that chemical reactions could create a steady, reliable flow of electricity, is pretty much the reason we have batteries today. Every single experiment we do, from that lemon battery all the way to a complex gadget, is standing on the shoulders of his work. So thanks to Volta, we have the volt. But what even is it? Well, the easiest way to think about voltage is like electrical pressure. It's the push that gets all the electrons moving through a wire. Kind of like water pressure in a hose. The higher the voltage, the stronger the push. All right, I know what you might be thinking. This all sounds great, but what kind of expensive gear do I need to buy? And the good news is, your first toolbox, it's going to be super simple and definitely not scary for your wallet. We're not talking about a huge investment to get started. I mean, just look at this list. Alligator clips, a few batteries, a handful of really cheap components, and some wire. That's really it. The barrier to entry here is so low. You can get everything you need to start messing around for just a few bucks.
Yeah, forget about soldering irons and all those complicated prototyping boards for now. Seriously, for our first couple of experiments, these little alligator clips, they're going to be your absolute best friend. They let you connect and disconnect things super fast and easy, which makes learning quick and, well, fun. And hey, don't you worry, we are going to get to all the cool stuff like breadboards and soldering, I promise. But each of those is a whole skill in itself, right? So they're going to get their own dedicated explainer down the line. The whole point of this series is to build your skills one step at a time. So for now, simple is the way to go. All right, now, as we're getting started, it's just as important to know what not to do. Trust me, knowing the common mistakes will save you a ton of time, money, and frustration. It's the key to making sure this hobby actually stays fun. Okay, if you remember only one single thing from this entire explainer, please make it this. The absolute, by far, easiest way to fry a component or even your whole project is to move wires around while the power is on. Always disconnect your battery first. It's a simple habit that will save you from a world of hurt. So, besides our number one rule, you'll want to watch out for short circuits, especially on a breadboard, and we'll talk all about how those work later. And you also need to know about something called electrostatic discharge, or ESD. Seriously, avoiding just these three things will make your learning curve so much smoother. You ever get a little static shock from a doorknob? Yep, that's ESD. But here's the really wild part. A shock that's so tiny you can't even feel it can be more than enough to completely and permanently destroy a sensitive electronic part. It's like the silent killer of chips.
Okay, so we've covered the basics, the tools, and the big warnings. Now for the really exciting part. Where does all this stuff lead?
let's take a quick look at the incredible journey from a single, simple component to the devices that pretty much run our entire world. It all just exploded with the invention of the transistor back in 1948. This tiny little switch replaced those huge, hot, unreliable vacuum tubes. Then came integrated circuits, like the legendary 555 timer, which put a bunch of transistors into one little package. And today, forget, we have entire computers on a single chip.
That's not an exaggeration. The device you're watching this on right now has chips with billions of those transistors packed into a space smaller than your fingernail. It's just an insane feat of engineering, and it all starts with the simple principles we're learning right now. And this is where it gets really powerful for you. As you follow along with this series, you are going to learn how to control these tiny computers, these microcontrollers. You'll be able to program them to read sensors, to control motors, and to bring your own unique ideas to life.
So, that was the grand tour, from a little spark on your tongue all the way to a computer on a chip. We've definitely covered a lot of ground, but remember, this whole explainer was just the orientation. Think of it like the map for the journey we're about to take together.
And that brings us to the big question, the one I hope is already sparking in your mind right now. What will you build? A blinking light? A little robot? Maybe a custom security system for your room? The possibilities are just endless, and it all begins with the very next simple circuit you put together.
The most important thing to take away is that we've just laid the groundwork. We've introduced the big ideas, the tools, the history. Now, in the explainers coming up, we're going to dive deep into every single one of these topics, building up your skills and your knowledge piece by piece. And just to give you a little taste of what's coming up next, we're going to show you how to master the breadboard, really understand core components like resistors and capacitors, build your very first transistor circuit, and yeah, even program that tiny computer we talked about. Your journey has just begun.